All right, good morning, everyone. Good morning. Day 2 of the conference. Hope everybody's doing well. We're going to go ahead and start with our session this morning with Mr. Jesse Rouse with Coastal Carolina University and his topic today. Thank you.
Yeah, so now that I'm back in North Carolina, it's always the question, isn't that a community college? No, we're down in South Carolina. I just jumped ship from UNCP down to Coastal Carolina, but still wanted to talk about some of the work we've been doing through the Robeson County Groundwater Monitoring Project that we've been doing for a few years now. It's going to be more of a qualitative discussion, it's a descriptive discussion, as opposed to getting into some of the quantitative aspects between some of these issues of scale and of edge effects that we'll see, but it's really just to kind of highlight how the different sampling strategies that we've been looking at and access to different scales of data are kind of giving us new ways to look at this, but also questions that we're trying to overcome for the county of Robeson County. And if you're not sure where that is, I guess I should have made a map of that. But it's basically just south of Fayetteville. We're between Columbus County and Scotland County. And if you've ever driven down 95 through Lumberton, you're going through Robeson County. Excuse me. So the task for this project, excuse me, shouldn't have had orange juice beforehand, is to basically support Robeson County utilities. The University of North Carolina at Pembroke has been contracted by the county to basically go through, do monitoring of groundwater levels. We're not doing testing for what's in the water, just water levels at this point. It's basically been a discussion since 2016, but we didn't start really collecting data until the end of 2017, and first full year was 2018. It's a long-term monitoring project, which we're doing on a excuse me, every couple of years rolling basis. But as we look at this and move forward, we're hoping to be able to expand a little bit more, get into some of those things in terms of water quality as well as water levels. We're using existing wells. Of course, NCDEQ has a large number of wells in this region of the state. USGS has a few wells as well. But we've also specifically are using 13 wells, some of them purpose drilled, some of them already existing for the county to be able to keep an eye on what's going on in this area. Now, the wells that we're looking at are primarily, as I'll talk about, in the county, but we're also using other wells to get around some of these edge effects. Here you can see our array of wells. The ones in green are our project wells specifically, but we're also using these NCDEQ wells, which are in purple, the blue wells, which are USGS wells, and the red dot just over the border is a South Carolina well. Now, we are working in the Black Creek Aquifer, so we're kind of confined in terms of who has access. We're looking at those wells that are within 50 miles of Robeson County overall, but there are some limitations in terms of access. And of course, we're actually able to look at this at a higher sampling density than perhaps some other areas. Whenever we talk to the state and others, they're using just those that are in purple. So we're getting a little bit more detail in this area, and that's kind of helping bring out even more questions for us to look at in the future. In terms of how we're doing this, there's a few different things we're doing. Primarily, we're looking at pressure sensors in the wells that are collecting every 30 minutes. We're taking that data, of course, averaging out to day to week to month, and we'll look at month data in a little while. We're also going out, and as we're collecting this data, since we're using not wirelessly available data, we're going out and collecting the data with computer, but also doing ground checks of the well depths at that point. So we have this other data so we can have these comparison points between what's going on in the sensor based on the pressure and the actual physical measurements. Like I said, we're collecting the data once a month. And with that, this is being done primarily by undergraduate students. They're going out, they're getting hands-on experience in how to collect data, how to use some of the newer technologies, how to do very traditional sampling in terms of both just figuring out how low the water is or high the water is at that particular well location, but also beginning to do some other water sampling and pumping and those type of things to make sure that they're a little bit more familiar whenever they get out into the field with what would be expected of them in these hydrogeology jobs. As we look at the data, and this is just one of our wells. This is Alamac. We're also seeing various things that are coming through in the data, and that's why we wanted to be able to look at wells besides our own. A couple of wells that we drilled are very close to existing DEQ wells, so we can have these comparison points. And we also drilled a couple right next to each other as well, so we can have comparison points between those to make sure that our well sensors are, giving us data that is usable and reliable, hopefully. And like I said, the data that we're going to be looking at today is largely going to be focused on monthly averages. Now, some of the acquisition issues we've run into, again, whenever you're going out with students and even whenever you're working with folks who aren't hydrogeologists, such as myself, we get a little bit of human error. And within this, I just wanted to highlight a few of the things that we've come across that I or some of the students have created, and luckily either I or Dr. Maharajan, who is our hydrogeologist, have been able to figure out. Some of these we adopted whenever we took over the role of leading the project in 2019. But one of the big ones was sensor calibration. The first time that the sensors were put in, the person who was leading it before us I think he thought he had a different sensor because he was putting it a little bit too low beyond what the sensor's range was. And so it was getting too much pressure, and we weren't really seeing a lot of movement. We were able to calibrate those to get some of that data back, but one of the things you have to be mindful of is your placement of sensors as you're putting them out. We also had some sensor loss over time. This is one of those things that you expect to see 5, 6, 7 years down the line as the sensors get a little bit older. Unfortunately, whenever you have folks who aren't paying complete attention the first time they're doing it, just screwing the tops back onto the sensors before they go back into water, they don't realize that there's going to be a little corrosion from that, and we lost sensors from that. And we've had issues with batteries in these particular sensors as well. So very much things that are easy to deal with, but it's one of those things that whenever you lose a month's data because of one of them, that data is lost. So we have gaps in our data here and there because of some of these human issues. And we also had the fact that we were going with a single central barometric sensor as an offset for our pressure sensors. Basically, this is used to account for the changes in pressure in the water as the surface barometric pressure changes. And whenever we lost this one, luckily, of course, there's lots of freely available, accessible weather data with pressure information, so we were able to recover from it. But it's a simple thing that, we learn very quickly we need to have backups where possible. So getting into the topic itself, we're going to look at a few different things that are tied to scale, and again, tied to these edge effect issues. We're working with data that both is just in the county and, of course, having access to a wealth of data. USGS, of course, is national. They pull from a lot of the partner organizations, including state-level data like NCDEQ. And so whenever we look at some of this data in just a minute, you'll see that we do have these kind of ending at the state border. And you can kind of see these ISO lines from their potentiometric maps from 2021. And it just kind of stops. And, we know the aquifer continues. It's a logical thing, but whenever you're looking at modeling and relying on sample sets, it begins to have an impact on what your results will be. As we look at the county, where we have more data, we begin to get a little bit more variation. We begin to see some variations within the data that's not seen at that lower sampling level. And of course, we also have an additional 14 wells. We're not sampling these at 30-minute intervals, but instead 1 week intervals. But they still give us a very much higher spatial sampling compared to what we have at either state or county levels. So these are the 3 scales that we're going to be looking at in the next few minutes. So here, we're looking at, again, the ISO lines from NCDEQ's ncwater.org as well website. And you can go onto the site, put in the date range that you're looking for, and be able to get this. So I just went through and put in January 1st to January 31st, 2021, and then continuously through each of the months. And so as we look at these, we can see that, over time, with these temporal issues, that there is variation. As you'd expect, in the summertime, the water lines drift south, suggesting the water levels are getting lower. In the winter, they drift a little bit further north, which is suggesting the water's rising, as you would expect, with depletion in the summertime and then recharge in the wintertime. As we go through and look at these, we also see that there's a few areas that kind of stand out. And many of them aren't necessarily in the county, such as this dip over here around the Smith-McNair well. This is near a commercial activity where they have a fairly continuous draw on the water throughout the year. Now, this is looking at some of the temporal resolution possibilities, but we're also seeing, again, that we have this boundary at the bottom of the area. Now, this, of course, takes into account data that's not just in the state, let alone the county, to be able to get those edges, because again, the aquifer, whether it's called the Black Creek or other names that South Carolina also gives to this particular aquifer, continues on, and there is data for it. And so we do see along the edge a lot of information, and we'll see that as we continue on to talk about the county. Oops, wrong direction. Jumping to the county then, whenever we started with the person who was taking the project at the very beginning, we started with just the wells that we had drilled. And these are them. These are the 13 wells for the Robeson County Groundwater Project. Again, not all of them were purpose drilled, but some of them were already there in the area. Issues in terms of sampling, these are only in county-owned properties. So they're at schools, they're in parks, those type of locations. And so we're kind of limited in the places we could put wells. So you can see that in the western portion of the county, we get a little bit more. In the southern portion and northern portion of the county, we have fewer sample points. Whenever we create a potentiometric surface through these, we can see that in the south, as you would expect, because of lower elevations, we have water levels that have a lower height above sea level. All these numbers are above sea level over here. And then as we go to the north and west, we get higher water levels. So what we'd expect to see. The difference becomes whenever we begin to look at not just the wells that are drilled specifically for the project, but other wells in addition. Sorry. So here we have an addition just within the county, again, not moving outside of the county yet, of the data that's available from NCDEQ. So we can already see that in this northwest edge, we see more of a pull of that higher water level over into the northern portion of the county. We see lower water levels in the southern portion of the county. So we're seeing more of that blue, more of that orange in the respective edges. The issue still remains, we have a lot of areas that don't have points but are near the edge of the county. And this is where we wanted to see, okay, what would happen if we began to bring in data from outside the county? So in 2019 or so, we began to focus a lot more on bringing those wells that are within 50 miles of the border of the county into our analysis data set. All of these are empirical Bayesian kriging, using all the same formats, and all of these have been adjusted to the same legend within this data for comparison, for comparison purposes. As you can see, as we look at this additional set of data around the county, it gives us a much more representative, potentially, idea of what's going on in the county. As we go towards Scotland County to the west, we see there's a lot more depth in the water levels on that end. As we move towards Columbus County to the east and down towards South Carolina, we see a lot more shallowness, I guess you could say, in terms of the water levels down there. So we see a lot more of that darker orange in the northwest, more of that darker blue in the southeast. And as we compare these side by side then, we're seeing the real impact of having a higher sample level as we go through some of this. We can see also this impact on the far right of that one well on the outside of the county. So both the points that are just within the Robeson County groundwater on the left, the ones that are just within Robeson County itself from both sources in the middle, you don't really see much of an impact along that western edge until we get to that one where we're seeing the data that's coming from outside the county. And that's really where we begin to see more of an impact of that drawdown that's impacting potentially not just Columbus and Bladen counties, but also potentially that western edge of Robeson County. Now, again, we did this at different scales, not just at state, not just at county level, but we also wanted to highlight that, we have this data for campus as well. And here we're looking at a much shorter variation, and I forgot to put the scale on. So we're seeing about a 2-meter difference between the light blue in the north and the dark blue in the southern portion of campus. Now, we don't have access right now to other wells that we're utilizing for this. So again, we're kind of limited by and impacted by some of the boundaries that exist. So not the state-county boundaries that we saw before, but the campus boundaries that we're looking at now. As we look at these, clearly there's a variation from north to south. Again, just like in the county, this moves with the seasons. We have a lot of grass in Pembroke and on campus. So there's a lot of irrigation that goes on that pulls from this portion of the aquifer during the summer months. So it comes down pretty good in the summer, and then we see this recharge in the winter, just like we do in the state and the county levels. This kind of gives you a context that we're right next to town. You can kind of see those lines for the roads in the background, but really it's more interesting whenever you look at it in the context of this county level potentiometric surface. So we see a little bit of variation here in the county level. Again, we've clipped it to just this visible area. Within this area, we're seeing about a 5-meter difference between height and low. And within that, then, we can see this detail of campus. And very much, we're seeing a lot more detail, as you'd expect with a higher sampling frequency in this small area, compared to the results of the potentiometric surface for this area from the fewer points for the county. Now, 2 of the points are on campus, so there is a little bit of an influence, but really it's just part of that averaged section between the 2. So what we've seen here today is basically, whenever we're looking at different scales, different sampling levels, we've got different things going on. We can, as we get more sampling points, we can get more detail, we can see more within the variations of the groundwater, as you would expect from any increased sampling level. That, of course, increases costs. Now, luckily, we've had the chance to do this because of the funding from Robeson County Utilities, but we've also been able to take advantage of other data that's out there to help us with some of the issues that exist around our borders within the county where we don't have data. There's also conversations that could be had about the deterministic surfaces that we could use through inverse distance weighting and those type of analyses versus the statistical surfaces that we're using from empirical Bayesian kriging. But that would be a different conversation. Really, I kind of talked about that at the last NCGIS a few years ago. So that's kind of it. Whenever we're looking at borders in this area, whether it's campus borders, county borders, or state borders, we are seeing some influences along those. And some of that is border issues, edge issues, and some of that is just having access to greater sampling levels in different locations. That's it. Thanks. Any questions?
So I saw you started in 2017, so you missed out on Matthew, but how did Hurricane Florence affect your study in regards to, did you lose any sensors and all that? Did you have issues collecting data? did you learn anything from the data that came from that you maybe didn't expect?
So we actually saw Florence, so it might have been 2016. I might have my dates wrong. But we do have Florence, Michael, Matthew in there. And which one was in, well, I guess it is 2017. But which one is?
Was Florence.
Okay.
In the 2016 was Matthew.
Oh, okay, so yeah, we missed Matthew, okay. So what you're seeing there in this spike that's in September, that's Florence. Surprisingly, Michael, which, you do see a little bit of it, but because there was already so much saturation, so much absorption, I guess, at that point, there's a whole conversation to be had about whether or not the aquifer is really confined in this area because it's right there by the Cape Fear and the lumber, if there is intrusion during these events. So that's a separate presentation that is probably going to be at the NCWRI in a couple of weeks. But yeah, there are those issues where we are seeing kind of response rates, which we wouldn't really expect from a confined aquifer, but we are seeing those during these type of major water events. Yeah.
You mentioned commercial facilities and one of the things being kind of a drawdown. Have you reached out to some of the other manufacturers in the area, like Moores or anything else, to see what their monitoring levels would add to your data set?
I have not, because I'm not the hydrogeologist. I'm just taking the data they're giving us. So I don't think he has. I think that, a lot of it's, that's literally coming from your data sets. So, we're getting that from there. But there are a few other commercial activities that are going on in the county and now we're seeing, more movement of poultry into the county as well. So that's probably going to begin having an impact. And we don't necessarily have a lot of wells in the areas where we see some of the larger facilities come in. So we are looking at potentially looking at new well locations in the future as we get more of these type of things going on. But again, we've kind of been limited to looking at the public data and public locations as opposed to going to the commercial facilities. We've looked at, but I don't think we've talked to the local municipalities that have water systems as well. And we know that's another whole range of potential locations that we could be testing to give us even denser sampling rates.
Does DEQ currently track large-scale groundwater users like industrial and ag facilities?
I'll defer that to DEQ folks. Do you have a response to, do you track some of these folks you're talking about?
There are some large users with cretaceous aquifers that, but I don't, it's been so long since I've looked at it, I don't have the information on that.
Yeah, I didn't know that was a commercial facility until last time I talked, and someone from DEQ said, that's I think it's Campbell Soup over there, or something like that. That's that drawdown. So I think they know. But at the same time, with commercial activities changing so much, sometimes you don't notice it until the water starts going down. Okay. Well, thank you all, and have a good day.